My name is Orlando Osorio. I'm a former software architect at BodyLogicMD, and I'm gonna talk about our journey adopting FHIR and our implementation and modifications to adapt it to our use cases. BodyLogicMD was founded in 2003, and with over 50 locations across the United States and treating over 80,000 patients, it's one of the most prominent companies in the bioidentical hormone replacement therapy space in the United States. Since 2003, the BLMD software grew organically, sometimes with custom-made solutions, other times systems were adapted to varying use cases over time, and a lot of glue code to synchronize or move data between the systems. And a lot of these systems had been almost abandoned or written by devs who had left the company a long time ago. So you can see like an abstract representation of how it how it felt back then in around 2017. So you can see the color boxes representing patient data and how like sometimes there were duplicates or conflicting information or slightly different views of the same piece of data, and a lot of processes trying to keep them in sync. Sometimes just manual process and other times like automatic processes that could fail and then like have inconsistent representations of the data. Now, this started leading to issues with like the view that the company was giving to the patients via like the patient portal or customer support. This led to leadership to come up with a new company-wide strategy, later known as like the one patient strategy, which meant that regardless of what the focus of a department or a team was, we needed to always be mindful about like the patient's journey and the patient being one individual, right? So even though you could be focused on maybe the shipping of some supplements to the patient or the lab results, like it was the same patient who had an appointment next week um, with the doctor. From a technical standpoint, the decision was to unify and centralize the data. Now, this brought a few challenges. The main one being how to reconcile all of the different systems. So we had multiple teams very opinionated about how things should work. And sometimes they had different terms for the same concept, sometimes slightly different representations of the same essence, and sometimes just irreconcilable differences. We started looking at some like very dynamic solutions like RDF, but the main challenge kept coming back to like how to reconcile the different views and the different ideas from the different departments and teams. And like as developers, we didn't have the quote unquote authority to decide what approach was the correct approach. Around that time, we learned about FHIR. So FHIR at first seemed to be the solution to all our problems. If we could adopt it as the language of the system, that is like having the FHIR model and the names and terms and workflows be at the core of our new system, we would be able to leverage the authority and experience from a mature community and hopefully have a solution that could last and evolve. So the goal was to unify all of the data into a FHIR center, a FHIR core, and then build on top of that the different apps and logic and rules and workflows that we needed to build the entire system. This would also allow us to have independent development teams work in parallel, which was also one of the requirements that we had. Now, after prototyping and like starting doing some of the work of translating to FHIR, we soon hit our first roadblock. So there were a lot of like obscure cases, like around like 10 or 20% of the use cases that we had to implement. They didn't align nicely with the FHIR specification. So in these scenarios, we went to the community for guidance, and sometimes like our use cases were not 100% aligned. Other times, like they were completely out of the scope of FHIR, and in some other cases, like the response was like you're doing it wrong. That thing you're doing doesn't make sense. But again, like we had to find a solution to that case. So over and over, the recommendation for those cases was use extensions. And extensions, while they're great for interoperability, since like if you give me a resource with a bunch of extensions, I don't have to know anything about the extensions and able to parse it and store it or pass it along. Um, it's not great for development, which was like the main use case that we had, right? Like we wanted to build a system on top of FHIR. So as you can see in like the examples, like the difference between having something from the core, which in a programming language you can like do things like patient.gender. If you're using extensions, it's very convoluted and like, basically you have like a bag of dynamic data that you have to know by URL, and overall it felt in our prototypes that we were living in two separate worlds. The nice, clean core world where things would map nicely to UIs or the logic that we were writing, and the other world where we had to go through different hurdles to get to the data. Not only that, but some of the libraries and implementations that we had would need to be different depending on whether you were using a native attribute or an extension. And to make matters worse, like we needed a few custom resources that were outside of the FHIR spec. And for those cases, the recommendation was use basic resource type and just add extensions, which made things even worse because like now we had like three different ways of getting at the data. One was 100% extension based, another one a hybrid, and then the native resources. Um, and we also needed to encapsulate some of the processes that we had and needed to create custom operations. Then we found Aidbox. So Aidbox is a FHIR server with a developer-centric approach. And first of all, it's metadata driven. And what this means is that Aidbox at its core doesn't really care about what is the FHIR core spec. Instead, it just takes the FHIR spec as a configuration argument. And then based on that, it creates tables and indexes and instruments routes and publishes endpoints and does everything required to function as a FHIR server. Now, what this meant for our use case is that we could provide our own structured definitions, specifying our extensions and get first-class extensions and custom resources. So our custom parts would interact nicely with the rest of the FHIR core. In fact, it would be native, right? It wouldn't be a difference between them. So includes, rev includes, like access control rules, endpoints, like all of that would just work natively. And then we would like just solve the problem of having two separate worlds. It would be same thing for our case. Another nice thing that Aidbox provided was the app model. So the way this works is that you can provide your custom implementation of pretty much whatever you want. So you can create or provide your own implementation for things like $ summary, or you can just publish a like completely new operation of your own and provide the implementation. And also to intercept some routes and say, okay, instead of going the default route for this, use this code, which is more efficient. And another thing that I would highlight is the architecture of Aidbox. So instead of being a black box that like you get a FHIR server with an API to interact with, you get a very tangible runtime and database in the sense that it is meant for you to interact with at every level of the stack. So for example, let's say you need to squeeze some performance for some process, you can connect directly to the database and the model makes sense and it's supposed to be like it's open. It's another type of API. You even get some nice high level functions that solve very common problems like terminology bindings and getting some um, like getting into codable concepts and filtering by systems or finding references and some other nice things at the lower level. And same thing with the runtime, you get a lot of insights and data. So we knew that the ability to modify FHIR and get first class extensions could become a sort of slippery slope that could send us back to where we were originally. That is, not being sure about what the best way of doing things is or having to reconcile opinionated approaches. And we wanted to be extra careful with all of this. And so we came up with three main rules that we needed to follow before doing any customization. Rule number one was to not reinvent the wheel. What this meant was before making any decisions, we needed to really look for an existing solution in the FHIR spec or to ask the question in like to the community and try to always prioritize an existing solution, even if it didn't align 100% with what we wanted or was maybe a bit convoluted for what we wanted. Um, we would always try to favor an existing like FHIR approved solution instead of coming up with our own. Rule number two was to never break FHIR. So even if we were to do any extension, we could never, like for example, change the signature of an existing type or attribute, or break something semantically, or for example, using a field that had the needed data type but didn't make sense semantically for what we wanted to do. And number three was to take a bit of the same approach of like consensus-based design instead of like being super agile and just add a few columns to a table and move fast and then migrate later when we know better. So we kind of started doing a sort of implementation guide. Um, Back then, implementation guides were not as mainstream as they are today, or at least we were not that aware of them. But we ended up doing something similar. So we would spend time on like discussing and designing and explaining like why and how we were doing what we were doing and documenting it. Um, so after all of that, we ended up using over 60% of the existing FHIR resource types and added 5 new types and over 100 attributes and more than 40 operations. So this is the final architecture. You can see at the center the FHIR core, which is based on Aidbox. And on top, we have the different clients of the FHIR core. So we built in an EHR and a patient portal, operations app for customer support and operations staff, and a bunch of other apps and widgets and different ways of visualizing sections of the data. Then on the left, you can see the like backend processes. So each of them was a Docker container that could connect to the database or the FHIR API or a version of the FHIR API, an internal FHIR API, or subscribe to events. One thing to notice is that none of the containers would talk to each other. So they would be more async usually. So they would communicate between them using tasks. So like that's why we were calling like the language of the system. They didn't know of each other, and they would just like create resources or modify resources, and then other um, services could read them or react to them. And so each of them could be developed in isolation by a development team who knew the scope of what they were doing. And that gave us a lot of speed, development speed, because like the scope was very clear from the get-go. So for example, like the calendar service knew that the main goal was to synchronize appointment and schedule resources with the exchange service. So we could react to the events of the appointments being changed, or push updates from the calendar, from the actual live calendar. Same thing for the laboratory service. We could like be connected to Quest and LabCorp and others, and take the resources and create diagnostic reports or amend the reports, and all of that. We added CDS hooks, and we also had an analytics layer. Aidbox now provides an analytics engine. We didn't use it like back then; it didn't exist, so we built our own. But yeah, we also had some reporting on that side. Um, this FHIR, like public-facing FHIR API, was secured by an access control layer, which is based on the Aidbox access policies that we'll get into in a minute. One of the scenarios that I wanted to highlight, because I think it's interesting and it showcases the flexibility of our solution, is the how we dealt with multi-tenancy. So BLMD is a franchise, and it has very sophisticated rules about like how and when can a practitioner look at a patient data, and also like what data from that patient. The way it works, like a very simplified version of it, is that we have a tree of organizations. We modeled this using the FHIR organization resource and using part of to model the hierarchy. So you, as a practitioner, you're able to access data from the patients that belong to your subtree. So, for example, in the picture, practitioner Charlie can view patients from BLMD of Miami, while practitioner Alice can see patients from Miami and from Virginia. Now, depending on the role of the practitioner, that determines what type of operations you can perform on those patient records. So, for example, what scope of data you can read, or what, like whether or not you have write access and to what data point, or what type of operations you can invoke. So to do this, we kind of created three main areas or types of access. One was access to knowledge resources. This was pretty much open to any authenticated user. So here we would have terminology and knowledge artifacts like medication knowledge, or like, for example, like the type of laboratories we had listed or pharmacies. Then we had patient um, specific requests, which were usually invoked from the patient portal. So a patient accessing their own data based on the patient compartment, and then practitioner access. So practitioner access could go through the organization compartment or patient compartment or even practitioner compartment in some cases. Now, this is one of the examples of being metadata driven. So for example, FHIR uh, only lists a handful of compartments on the spec, but we just created a compartment definition, and Aidbox would create everything needed to have an organization compartment, which is not part of the FHIR spec. Um, so our access control policies would check the URL and the body of the request and perform an analysis and to determine whether or not the request was valid. In order to do this, we had to cache a lot of the relationships for performance reasons. But we were able to do all of that and leverage the power of like Postgres or the access control layer from a programmatic standpoint, and have a very performant access control layer that would not only respond based on the structure and relationships between the FHIR resources, but would also use custom FHIR resources and data from external identity providers. So yeah, I think this was a very good example of like the pragmatism of being developer oriented that allowed us to implement this efficiently and have it work. So the results overall from like start of development and research and prototyping, it took a little bit under 2 years. We ended up consolidating like around 9 systems. We consolidated a bit more, but they like some of them were migrated later. Um, After going to production, the migration time per practice was like averaging 1 week, which is very good. And after running for a long time, the average response time of the web apps was around 200 milliseconds, and I think the 95th and percentile was like 400 milliseconds. So overall, it was a huge increase in latency and like performance overall. Um, Besides consolidating multiple systems and providing better um, experience in general, we also integrated with a lot of third parties. We deployed an e-prescription module based on DosePod, integrated and certified integrations with Quest and LabCorp, integrated a payment solution using Square, also integrated with Office, like Exchange for the calendars and emails, Twilio for SMS, and a lot of other smaller integrations. And by going, like by consolidating the systems, we ended up also cutting costs, hosting costs by like $10,000 a month. So I have some screenshots of the applications built on top of the FHIR server. So for example, this is the a view of the EHR on the medications page. We had views for laboratories and questionnaires, financials and documents, care plans and communications and intake. This is the DosePod integration UI. This is a fragment of the operations app, just a like a task management system for um, customer service and operations staff. Um, this one was based on like mainly based on the FHIR task resource, and this is a good example of like the value of having first class extensions. So, for example, we used a lot of dependencies for the tasks. And at that time in R4, at least tasks didn't have any like notion of dependencies. So it was very useful to have them first class for like performance and filtering and logic and all of that. These are some screenshots of the patient portal in mobile view. So you can see like the calendar integration with the location and the drug view and the questionnaire view. Thank you.